Let's try to understand one of the big mistake some of the calculus students do. Have you seen like some of you write 1 over x dx equal ln x like that. So this is actually incorrect in two different ways. So let's see what exactly happened here. So the first thing is, so first mistake that you do is you forgot the plus c here. So that's very important. So you forgot plus c. So there is no c term. The c term is really important, and you can see that the c can be any number. So that means there are infinitely many values of c. So that means you pretty much forgot infinitely many solutions, and out of them you write only one. So that is the reason why this is correct only 0%, because you forgot infinitely many solutions. Okay, so let's look at the second problem. So this is the second problem. Actually, it should be ln absolute value of x plus c. So the correct answer is 1 over x dx equal ln absolute value of x plus c. So write absolute value properly. Don't write this as a parenthesis. So why is this? So let's try to understand the second argument. So otherwise, what will happen? You do not have 50% of the solution. And this is the argument. So let's look at the graph, and it will be very clear if you look at the graph. So the graph of ln x is like this. So we're going to graph the ln x function. So this, you know this graph. So it's going to go like that, and then it's going to meet at 1. So this is a graph of natural log x. So this is a graph of ln x. So, and you can see if you pick like a random point, like for example, you pick a point right here, and if you draw the tangent line, so there's a tangent line. So you can see that the slope of the tangent line is simply 1 over x. So the slope of the tangent line, so that's why we write this one as d by dx ln x equal 1 over x. So everything is fine so far. And then, but when you write integral of 1 over x dx, that means the most general antiderivative. And also like this solution is valid for x positive, just positive. So when you write the ln x, when you write 1 over x dx, that means the most general antiderivatives. This means the general, most general antiderivative. And that is actually the problem, because it should be the most general one. You can't just pick part of it, because you have only the solution for x positive. What about x negative? So let's look at the other side of the graph. So there's another graph. If you look at the absolute function, ln absolute value x, this is what happened. So we're going to graph ln absolute value x. So what will happen is going to jump to the other side. When you take the absolute value, you get the mirror image across the y-axis. So that means the graph is like this. So this is what you get. So you get two branches. You're gonna get one for the positive x and one for the negative x. So this is for the positive x, and this one is for the negative x. And interestingly, both of them, you can see if you take the derivative of the ln absolute value of x, you can see the derivative is actually ln, not just l, ln absolute value of x, and you can see that it is 1 over x. So only time this is not valid is when x equals 0. So you just remove 0. So that means otherwise the solution exists. So that means the most, so you see in both of them, so it's the same derivative for both sides. So that is the interesting point here. So you can see, so that means if you write the integral of 1 over x dx, it should be ln absolute value of x. So remember this one, this is like a very important fact, and most of the students forget the absolute sign, and then because of that they lose a lot of points. So I hope you learn this one right now, and hopefully you use this one in exam. And again, if you look at the derivative for those two branches, and you can see the slope is 1 over x in both cases, for the positive and also for the negative. So you can see they all have 1 over x as the derivative in these two cases. So if you do not have absolute sign and c, IO means infinitely many solutions. So that means mathematically your solution is correct 0% correct. So I hope you understand my argument. Okay, so thank you so much for watching.